Vast distances, untold secrets. What lies beyond the edge of the visible universe? Embark on an incredible journey to the frontiers of knowledge, where billions of galaxies hold the secrets of the universe's birth and death. Greetings, explorers of infinity. Today, we're launching an extraordinary quest, not just to the stars, but to the farthest reaches of our cosmos, the deep space. What exactly is it? It's more than just the emptiness between planets, or even beyond our solar system. Deep space begins where the Milky Way ends, stretching billions of light years in all directions, encompassing countless galaxies, their clusters, colossal cosmic filaments, and voids that shape the grand architecture of existence. Consider the scale. Light from the most distant objects we can observe has traveled for billions of years to reach us. That means when we look at them, we see the universe as it was in its infancy. Every photon reaching our telescopes is a message from the ancient past, a story about the birth of stars, the formation of galaxies, and the first moments after the Big Bang. It's a time machine, made possible by the laws of physics and incredible technology. Exploring deep space isn't just academic curiosity. It's humanity's fundamental quest to answer the biggest questions. How did the universe begin? What is its fate? How do galaxies, including our own, form and evolve? We strive to understand not only what we see, but also what's hidden from our eyes. The enigmatic dark matter and dark energy, believed to comprise up to 95% of the universe's total mass and energy. We, as humans, are inextricably linked to this grand cosmic tapestry. The elements that make up our bodies, carbon, oxygen, iron, were forged in the hearts of dying stars billions of years ago and scattered across the universe. We are, quite literally, stardust. Understanding deep space isn't just about expanding our scientific knowledge. It's about deeply realizing our place in this infinite, ever-changing, and astonishing reality. It helps us appreciate the uniqueness of our planet and the fragility of life. To delve into deep space is to dive into the history of existence, into the physics of its most extreme manifestations, and into the potential of its future. Prepare yourself because this journey is just beginning, and each new chapter will reveal exciting new horizons of discovery. Did you know our most powerful telescopes aren't just lenses, but time machines allowing us to glimpse the universe's distant past? On our journey through deep space, we've grasped its incredible scale and how light from distant objects carries information from the past. But how can we, inhabitants of a tiny planet, look billions of years back in time? The answer is both simple and astounding. Through our eyes, telescopes, our very own time machines. For decades, the Hubble Space Telescope has been our trusty guide into the depths of the universe. Launched in 1990, it has given us thousands of breathtaking images that have revolutionized our understanding of space. Hubble showed us the birth of stars and nebulae, colliding galaxies, and even allowed us to refine the age of the universe. Its images have become not just scientific data, but also works of art, inspiring millions around the world. But science never stands still, and Hubble has been succeeded, or rather complemented, by a new giant, the James Webb Space Telescope. Launched in late 2021, Webb operates primarily in the infrared. This is crucial because light from the earliest galaxies stretches and reddens as it travels towards us, shifting towards the infrared spectrum. Webb can capture this ancient, stretched light, allowing us to see the universe as it was just a few 100 million years after the Big Bang, when the first stars and galaxies were forming. It's literally a glimpse into the infancy of the cosmos. But it's not just optical and infrared telescopes that help us. Ground-based radio telescopes like ALMA in Chile or the VLA arrays in the USA offer a completely different window into the universe. They capture radio waves that can pass through dense clouds of dust and gas, which block optical light. This allows us to study the cold gas clouds where stars are born, explore accretion disks around black holes, and discover the most distant galaxies, which emit primarily in the radio spectrum. The time machine principle is simple. Light has a finite speed. When we look at an object 10 billion light-years away, we see it as it was 10 billion years ago, because that's how long it took its light to reach us. The farther the object, the deeper into the past we look. This allows us not just to see a static picture, but to observe the evolution of the universe dynamically, layer by layer. These incredible instruments are the fruit of human genius and the desire for knowledge. They expand the limits of our perception, allowing us not only to look at the stars, but to read the history written in light and unravel the great mysteries of the cosmic world. Prepare to have your mind blown. Our telescopes reveal that space isn't just empty. It's filled with billions of galaxies, incredible star islands, each living its own unique life and interacting with its neighbors. Our journey into deep space continues to reveal its grand scale. If in the first part we talked about the vast expanses, and in the second about the eyes with which we see them, now let's focus on the inhabitants of these realms, galaxies. Imagine not just single stars, but entire star islands, each potentially containing from several million to trillions of stars, as well as gas, dust, and of course, enigmatic dark matter. Billions of these islands are scattered throughout the universe, and each is a separate world with its own history and fate. There are three main types of galaxies, each with its own unique character and appearance. The most recognizable are spiral galaxies, which include our Milky Way. They have a bright central bulge and thin, beautifully curved arms where young stars are actively born. These arms are rich in gas and dust, giving them a bluish tint due to the glow of young hot stars. Their elegant structure is the result of a complex interplay of gravity and rotation. Then there are elliptical galaxies. They are very different from spiral galaxies. They are huge, smooth spheres or ellipsoids, consisting mainly of old red stars. They have practically no gas and dust, which means that star formation is very slow or non-existent. They can be both dwarf and giant, dominating the centers of galaxy clusters. It is believed that many elliptical galaxies formed as a result of grand mergers of several spirals. Finally, there are irregular galaxies. As the name suggests, they have no clearly defined shape. They look chaotic, as if someone scattered stars and gas without any order. Often, this shape is a consequence of strong gravitational interactions with neighboring galaxies, or even collisions. Despite their irregularity, they are places of very active star formation, as gravitational disturbances compress gas clouds, triggering new cycles of star birth. But galaxies don't exist in isolation. They are constantly interacting with each other under the influence of gravity. This cosmic dance often leads to dramatic events, mergers and acquisitions. When two galaxies collide, it's not like a car crash. The stars in them are so far apart that a direct collision is extremely unlikely. Rather, they pass through each other, their gravitational fields distorting shapes, stretching out gas and dust, and provoking bursts of star formation. Ultimately, they can merge into one larger galaxy, often elliptical in shape. Our Milky Way, by the way, is expected to merge with the Andromeda Galaxy in a few billion years. These star islands are not just scattered randomly. They form grand, large-scale structures of the universe. Galaxies gather into clusters, clusters into superclusters, which in turn line up in giant filaments, separated by huge voids. This cosmic web is the result of gravitational attraction acting over billions of years. We ourselves are part of the Laniakea supercluster, a giant structure uniting tens of thousands of galaxies. Understanding this hierarchy helps us comprehend how the universe evolved from a homogeneous state after the Big Bang to the complex hierarchical structure we observe today. Imagine a flash of light so blinding it outshines billions of stars in an entire galaxy, or an object spinning at such incredible speeds that its beams pierce space like a high-powered lighthouse. In the depths of the universe, such phenomena aren't fiction, but harsh and majestic realities, ruled by the most exotic and powerful cosmic phenomena. In our endless journey through deep space, we have already encountered galaxies, these majestic star islands. But what drives them? What forces shape them? And what are the most extreme objects we can find in their depths? Today, we'll dive into the world of cosmic phenomena, ruled by quasars, pulsars, and of course, enigmatic black holes. Let's start with black holes. These aren't just holes in space, but regions with incredibly strong gravity, so powerful that even light can't escape it. They form from the remnants of very massive stars after their collapse. But in the centers of most, if not all, large galaxies, including our Milky Way, reside supermassive black holes. Their mass can reach millions or even billions of times the mass of the Sun. These giants play a key role in the evolution of galaxies. The gravitational field of a supermassive black hole affects the movement of stars and gas in the central regions and can also regulate the rate of star formation. When gas and dust fall onto such a black hole, they form an accretion disk that heats up to extreme temperatures and emits colossal amounts of energy. This process leads to the appearance of quasars. A quasar is nothing more than an extremely bright active nucleus of a distant galaxy, powered by a supermassive black hole that is actively absorbing matter. They are so bright that they can outshine the light of all the stars in their galaxy, making them visible at the greatest distances. Observing quasars, we see the universe in its turbulent adolescence, when black holes actively fed and grew, forming the galaxies around them. These cosmic beacons give us a unique opportunity to study conditions in the early universe. Now let's move on to pulsars. These are completely different objects, but no less amazing. Pulsars are rapidly rotating neutron stars, remnants of supermassive stars that exploded as supernovas. After the explosion, the core of the star collapses to incredible density. 1 teaspoon of neutron star material weighs billions of tons. These stars have powerful magnetic fields and emit narrow beams of electromagnetic radiation, like a cosmic lighthouse. When such a beam passes by Earth, we register regular pulses, hence the name pulsar. Their incredible rotational accuracy makes them one of the most accurate clocks in the universe, allowing scientists to test theories of gravity, including Einstein's general theory of relativity. All these phenomena, from supermassive black holes forming galactic nuclei to pulsars born from the death of stars, are an integral part of the complex and dynamic life of deep space. They don't just exist, they actively participate in processes that determine the appearance and evolution of the universe. By studying them, we are unlocking more and more secrets about how our world is structured at the most fundamental levels. Get this, everything we see in the universe, stars, galaxies, planets, even you, makes up only a measly 5% of its total mass and energy. The remaining 95% remains invisible and mysterious, challenging everything we know about space. Our journey through deep space has led us to incredible discoveries, from the scale of the universe to exotic objects such as black holes and quasars. However, as astonishing as these phenomena are, they make up only a small part of what shapes our universe. Prepare for the most amazing revelation. Everything we see and can observe, stars, planets, gas, dust, galaxies, makes up only about 5% of the total content of the cosmos. The remaining 95% remains invisible, mysterious, and challenges our understanding of physics. This is the dark side of the universe, dark matter and dark energy. Let's start with dark matter. This isn't some kind of cosmic dust or ordinary matter that we just can't see due to lack of light. No, dark matter doesn't interact with light at all. It doesn't absorb, emit, or reflect it. We know about its existence solely through its gravitational effects. How did we discover it? In the early 20th century, astronomers studying the rotation of galaxies noticed something strange. Stars on the outskirts of galaxies rotated much faster than they should have, based on the visible mass of the galaxies. It was like spinning a ball attached to a string, but the string was invisible. To explain this extra gravitational attraction, the hypothesis of an invisible substance that makes up approximately 27% of the total mass of the universe was put forward. This invisible gravitational scaffolding is the foundation upon which galaxies and their clusters form. Without dark matter, galaxies would simply fly apart. Scientists hypothesize that dark matter consists of as yet unknown elementary particles that weakly interact with ordinary matter, but actively participate in gravitational processes. Even more mysterious is dark energy, which makes up approximately 68% of the total content of the universe. If dark matter attracts, dark energy, on the contrary, repels. Its existence was discovered relatively recently, in the late 1990s, when astronomers were studying distant supernovas. They expected the expansion of the universe to slow down under the influence of gravity. However, to their surprise, it turned out that the expansion of the universe is not just continuing, it's accelerating. It was as if you threw an apple up, and instead of slowing down and falling, it would start accelerating and flying away. To explain this accelerating expansion, the existence of some kind of dark energy was postulated, which acts like anti-gravity, pushing space apart. What is this energy? Perhaps it is a property of empty space itself, a kind of vacuum pressure, or a manifestation of a new, unknown force. The answer to this question is one of the main puzzles of modern physics. Thus, our cosmos is not just stars and galaxies. It is a complex puzzle where visible matter is just the tip of the iceberg. Dark matter provides the gravitational structure holding galaxies together, while dark energy pushes the universe toward accelerated expansion. Understanding these two mysterious components is key to unlocking the origin, evolution, and ultimate fate of our universe. The biggest challenges for modern astronomers and physicists who continue to seek answers using the most advanced telescopes and theoretical models. We've already glimpsed the universe's past, unraveling some of its mysteries. But what if the most incredible discoveries are still ahead? Prepare for an inspiring look into the future, where the human mind will continue to unravel the great mysteries of the boundless cosmos, changing our perception of reality forever. We've taken a dizzying journey through billions of light years, glimpsed the universe's past, encountered its galaxies, exotic phenomena, and the mysteries of dark matter and energy. But what's next? Have we learned everything yet? Of course not. Deep space is a bottomless source of questions, and humanity is only beginning to grasp its true depth. New, even more ambitious missions and instruments await us, promising to change our understanding of reality. The future of space exploration is incredibly exciting. New generations of telescopes are already on the way. The Nancy Grace Roman Space Telescope, scheduled for launch in the mid-2020s, will focus on studying dark energy and searching for exoplanets. Its wide-angle view will create vast maps of the universe, revealing the effects of dark energy. In the field of gravitational wave astronomy, the LISA mission awaits us. This space-based interferometer of 3 satellites will be able to capture gravitational waves from mergers of supermassive black holes and other massive cosmic events, inaccessible to ground-based detectors. LISA will open a new window into the processes occurring in the centers of galaxies and in the early universe. Extremely large telescopes of a new generation are being built on Earth: ELT, TMT, and GMT. Their mirrors, tens of meters in diameter, will collect light with unprecedented power. These giants will be able to directly observe exoplanets, analyze their atmospheres for biosignatures, and look into the earliest epochs of the universe with incredible detail. Radio astronomy is also actively developing. The Square Kilometre Array (SKA) project, under construction in Australia and South Africa, will become the largest radio telescope in the world. It is capable of studying the dark ages of the universe before the formation of the first stars, studying the formation of galaxies, testing the theory of relativity, and searching for signs of extraterrestrial life. In addition to new instruments, new concepts await us. Maybe we will discover traces of other universes within the framework of the multiverse hypothesis, or find evidence of the existence of wormholes? And what about exotic physics that we can't even imagine yet? Deep space continues to be the greatest source of inspiration and challenges for humanity. Each new discovery only opens the door to even more questions. This is an endless process of cognition that drives our civilization forward, expanding the boundaries of the possible and changing our understanding of who we are and what our place is in this amazing and magnificent universe. Our journey to the farthest galaxies will never end, because the universe will always hold new secrets. Our journey to the farthest galaxies has come to an end, but the exploration of the universe never stops. If you, like us, are fascinated by the boundless mysteries of space and want to continue discovering them together, subscribe to the Epoch Echoes channel. Here we will continue to unravel the great mysteries of the universe. And if this story inspired you, give it a like so we know we are moving in the right direction.